Alright, welcome to our notes on rewriting exponents. And this is the easy version. The next set of notes makes it much harder. So first and foremost, there's the question, what is an exponent? If you've heard of PEMDAS or GEMS for order of operations, exponent's the second thing you always do. So exponents in general, here's what it means. An exponent is like a number. It's really tiny in the upper right hand corner. So in this little expression right here, it's the 2 that's the exponent, because the 4 is the big, so 4 is the main number. And 2 is what you'd call the exponent. So in this situation, it's the 2 that's the exponent. Here's what exponent means. The exponent tells you how many times that you multiply the big number to itself. So it's how many times you multiply the big number to itself. So 4 with an exponent of 2 means technically 4 times itself twice. So 4 times 4. And 4 times 4 is 16. Okay? Now quickly, I want to explain a few ways I can say this. I could say this is 4 with an exponent of 2. However, people usually don't say that. People usually say 4 to the power of. And to the power of means exponent. So like this is 4 to the power of 2. This is g to the power of 5. K to the power of 7. Y to the power of 3. A to the power of 3 to the power of 4. So exponents, you can say with an exponent of, or sometimes they will, but mostly they'll say to the power of. However, there's 2 big ones that are common, which is an exponent of 2. So actually people call that squared. It has its own special name. So most people would read this as 4 squared. This guy here, 4 squared. The other thing that's pretty common is something to the power of 3. So let's say it's 2 to the power of 3. So that's 2 to the power of 3, or 2 with an exponent of 3. It means the same thing. But that one's also so common that people will say 2 cubed. So if you ever hear cubed, that means to the power of 3, or with an exponent of 3. So there's 3 ways to say it. It all means the same thing though. 2 cubed means 2 times 2 times 2. So you times 2 to itself 3 times. So 2 times 2 is 4, times 2 again is 8. So we're going to rewrite exponents and work on them. Yes. So here's a few things. For example 1, g to the power of 5. What that means is you're going to do g times g times g times g times g. So if we knew what g was, like if g was the number 3, it'd be 3 times 3 times 3 times 3 times 3. But when it's a letter, like g, we just write it like that. So this is the long version, this is the shorthand. So normally you're going to want to use the shorthand. But knowing what it means in the long version is important too. So the reason why we're doing this is just so you see what it means. Okay? So for example 2, k to the power of 7 means k, 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 k. 1, 2, 3, 4, 5, 6, 7. Yep, that's 7 k's being multiplied to each other. And when a letter, even if it has an exponent, is next to another letter, it means they're being multiplied. So it's still times the y cubed, but y to the power of 3 means y times y times y. So this is the long version of this. Example 3 makes it harder because you have two exponents. There's an exponent on a parentheses. So what that means is that if there's a parentheses with an exponent on it, that comes first. And it means I have 4/8 to the power of 3s. And they're all being times to each other. And I have 4 of them because there's a parenthesis around the whole thing that has an exponent of 4 on it. But now each a cubed means 3 a's being multiplied together. So this first one means a times a times a. That's that one. The second one is also times a times a times a. And the third one is times a times a times a. And then I have my fourth one times a times a times a. So that's how you do this one in the long way, with everything being multiplied out. So then there is this concept of when you divide. And you have to remember that anything divided by itself is 1, right? So they call that the giant 1. So if you have 10 divided by 10, you can put like a little 1 around it, like this. And it's like, draw a picture. Look, it's just 1. Because 10 divided by 10 is 1. Because if it's the same thing on top and bottom, it's going to be 1. Here it's because if I have $10 going to 10 people, each person's going to get $1. But in the same way, x divided by x is just 1. I'm not good at drawing the giant ones. Look, a 1. Because something divided by itself is just 1. Here's why that matters. When you get to example 4, it says g to the power of 9 divided by g to the power of 4. Well, on top, that means I have 9 g's all being multiplied to each other. Divided by g to the power of 4, which means on the bottom, I have 4 g's being multiplied together. Well, everything that's on top and bottom can become a giant 1. So these two can come together and be a giant 1, because there's 1 on top and bottom. These two can come together and become a giant 1. These two, and these two. And so those aren't g's anymore, they're all 1s. So 1 times 1 times 1 times 1 is just 1. So it's like they can all go away, because they're just 1s. And multiplying by 1 doesn't change anything. So if they all go away, really what I'm left with is 1, 2, 3, 4, 5 g's. And that would be my long term, or my long written form of this guy. Because there were things on top and bottom that could cancel because they became 1. So for example 5, I have 2 letters in there. I have g's and x's. First I'm going to write it all out. So I have 2 g's times 7 x's. 4, 5. And then on bottom I have 4 g's and 3 x's. So, because I'm multiplying, as long as it's the same on top and bottom, g divided by g is just 1. And there's another g divided by g. Now these two g's don't have any more to combine with. But if I go to these x's, look, this x has an x to combine with. That one has an x to combine with. And that one has an x to combine with. And so because they're on top and bottom, it just divides to 1. And so they can all go away. So really, I'm left with 1, 2, 3, 4 x's on top, divided by 2 g's on bottom, because all the rest of them went away because they became a 1, a giant 1. So, we have some rules to learn about exponents. And here's how it works. The first one's called the exponent product rule. And the word product means multiply. Okay? So you can see in the rule, here, right here, I'm going to write multiply, because that's what the word product means. And you can see this rule that says a to the power of n times a to the power of m equals a to the power of n plus m. I'm sure that makes no sense to you right now. So we're just going to jump to the example, and you're going to see what happens. And then I will go back to the rule, and then we'll put it in words. So it says 4 to the power of 2. So that means 2 4s being times together, times 4 to the power of 7, which means now I have 7 more. So 1, 2, 3, 4, 5, 6, 7. And if I tried to put that all back together and counted, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9 4s being multiplied together, which is 4 to the power of 9. So look what happened to those exponents. The exponent of 2 and the exponent of 7, they together, to get that 9, you end up adding them. Even though you're multiplying the 4 to the power of 2 to the 4 to the power of 7. With the exponents, because it's how many times you're multiplying something to itself, it's saying it's happening twice here, and it's happening 7 times here. So altogether, you're multiplying it 9 times. So going to this rule, a to the power of n times the same number, because it has to be the same, they all had to be 4s for this to work, to a different exponent, let's call it m. It says that what you need to do is take a and add the exponent, see, n plus m. So it's saying we add them together, the two exponents, to get our final answer. So in words, when multiplying, add the exponents. Okay, so the next name of the next rule is the exponent quotient rule. And so quotient is the big word for divide. So if you look to the rule, it says a to the power of n divided by a to the power of m equals a to the power of n minus m. I'm sorry. So if you look to the rule, it says a to the power of n divided by a to the power of m equals a to the power of n minus m. Now, in order to explain that, we're going to just do this example. So over here it says 3 to the power of 8. Remember that slash means divide, divided by 3 to the power of 2. So in order to write this out in long version, it's going to be 8 3s on top. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 2 3s being multiplied together on bottom. Well, for every top and bottom pair, I can turn them into a 1 and make them go away. So these 2 can become a 1, and these 2 can become a 1, which means I'm really left with 1, 2, 3, 4, 5, 6. So 3 being multiplied to itself 6 times. So if you look at the relationship between the two exponents, the 8 and the 2, and ending up with the 6, because they were on top and bottom and you're able to get rid of them, it's like you ended up subtracting them away. So this is what the rule says when you have a to the power of n divided by the same number, because they all had to be 3s for this to work, so a to the power of a different exponent. You end up having the answer as that a to the n minus m, when you end up subtracting the exponents. So in words, the rule is when dividing, subtract the exponents. When dividing, subtract the exponents. Okay, and then there's one more rule, which is the exponent power rule. So the word power means exponent. Because you know how I can say like 7 to the power of 4 or 7 with an exponent of 4. So the exponent's power rule means there's an exponent on top of an exponent. So it's because the whole thing's in parentheses and there's another exponent on that parentheses. So the rule says if you have b to the n all being raised to the power of m, the answer is b to the n times m. So let's work out a problem to see what that means. So remember, if there's a 4 on the parenthesis, it means that they want 4 of everything in the parentheses. So I want 4 5 to the power of 3's. However, each 5 to the power of 3 means that there's 3 5's. So this first one has 3. 1, 2, 3. This guy. Now my second gun has 3. 1, 2, 3. My third one has 3. And then my fourth one has 3. So if I add up how many 5's I have, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I end up having 5 being multiplied to itself 12 times, which is 5 to the power of 12. So if you look at the two exponents, they were 3 and 4. And how 3 and 4 get to 12 is by multiplying. Because I had 4 to the power of 3's, meaning I'll have a total of 12 of them. So back to the rule, b to the power of n, some number with some exponent, when raised to another exponent, let's call it m. What you do with the two exponents is you end up multiplying them. So the exponent power rule in words is when you have an exponent on top of another exponent, you end up multiplying them. When you have an exponent on top of another exponent, multiply them. Okay, so we're going to practice 10 of these really fast, not writing them out the long way, and only using the rules. So if you have 7 to the power of 4 times 7 to the power of 9, we're multiplying them, so that's the exponent product rule. And the rule says when multiplying, add the exponents. So it ends up being 7 to the 4 plus 9, because you have to add them. So it's 7 to the 13, to the power of 13. And that's the answer. So together, these two become 7 to the power of 13. Here is 3 to the power of 5 divided by 3 to the power of 3. So division is the exponent quotient rule, which says when dividing, you subtract the exponents. And so that means that you do 3 to the power of 5 minus 3, which ends up being 3 squared, or 3 to the power of 2. I realized I started going down instead of over, but this says 1 and this says 2. So I'm going to go in order. I'm going to go back 1. So here it's another multiplication one, which is the exponent product rule, which says we need to add the exponents. So that becomes 10 to the power of 8. b is 5 plus 3 is 8. And over here, when I come back to another division one, I go back to the quotient rules. And the exponent quotient rules is when dividing, you subtract the exponents. So 5 to the power of 4 divided by 5 to the power of 2 is 5 to the power of 4 minus 2, which is 2. So the answer is 5 squared. Number 7 is an example of the exponent's power rule, because there's an exponent on an exponent. So here's how it works. When you have an exponent on top of another exponent, you multiply them. So this becomes 5 to the 3 times 8 to the power of 3 times 8. And then if you do 3 times 8, that's 24. So the answer is 5 to the power of 24. Okay. If I do the next one, this one kind of combines a couple rules. So you always start with the furthest out parenthesis, which means we're starting with the fact that all of these have all of this is in the parentheses being raised to the power of 4. Which means when you have an exponent on an exponent, you multiply them. And that happens in both situations. So you do 3 to the power of 2 times 4, because you have to put this 4 with this 2. And then you also have times 3 to the power of 5 times 4, because you also have to put this exponent of 4 on top of that 5. And then after you multiply, you get 3 to the power of 8. And then in this parentheses, I have 3 to the power of 20. But remember, something in front of a parentheses just means you're multiplying it. So now I have a whole different rule, because I have two numbers that are the same, they're both 3, with some exponents being multiplied together, which means I can use the exponent product rule that says when multiplying you add. So together it becomes 3 to the power of 28, because you add the 20 and the 8 because of the exponent product rule. When you have letters, the rules are the exact same. So x to the power of 2, all being raised to the power of 5. Because there's two exponents on top of each other like that, it means you times them or multiply them. So you get x to the power of 10 for your answer on that one, because 2 times 5 is 10. Then for number 10, x to the power of 8 being raised again to the power of 3. Means you multiply the 8 and the 3, which is 24. So the answer is 8 to the power of 24.